Is it recording? I'll assume that it is. The first one, what am I trying to say? The point was to review the process of solving an equation, not so much just a square root equation. Why couldn't you just square right off the bat? You had to isolate this first, right? With most equations, there's something you've got to get by itself first. And that's what happened here. You add 4, you got 2x minus 3 is equal to 3. Now that you've got this something isolated, you got to undo that something. Most things in mathematics can be undone. If you square root something, you can square it to undo it. Now you've got 2x minus 3 is equal to 9. If you add 3, you get 12. If you divide by 2, you get 6. Pretty easy equation there to solve. And again, it wasn't just a square root that I was having you practice. It was the process of solving an equation. This one's a little bit different, part B. This isn't the case where you want to isolate something. If you have a quadratic like this, you got to get one side equal to 0. And then if it doesn't factor, you use the quadratic formula. But this one factors. So x equals -5, x equals -2. So here's where we're going with that. Oh, don't look. We've got that equation right there, 16 to a power of 3x is equal to 8. This is a new type of equation to solve, but it uses the exact same process as part A right here. There's something that you have to get by itself, and then you have to undo something by doing the opposite, and then you got to solve for x. So let's write down some steps. Just like on part A of that practice problem, you had to isolate the root. Here you've got to isolate the exponential term. That means get it by itself. Still not connected. No. So isolate the exponential term. This is one of the reasons we've even learned about logarithms, is you have to use them to solve this type of equation. Because here's the problem. Whether or not you've seen it as a problem, it is a big problem. What are we solving for in this equation? We're solving for x, right? You can't solve for x if it's an exponent. That's no good. But it's only an exponent because there's a base right there. What if we could somehow cancel the base? That wouldn't be an exponent. That would just be a 3x. So what cancels bases? Logarithms. That's the point of this lesson, is to see how logarithms can solve equations. That's why step 2 is to use logarithm on both sides. Once you've used a logarithm and evaluated, then you can solve for x.
Would you have to do the logarithm of 16?
Log base 16, yep.
Let's go next to
Now we actually don't have to do step 1 on this equation, because the exponential term is already isolated. Here's what it would look like if we had to do something for step 1. Would, let's see, let me put a 16 to the 3x minus 2.
just add 2.
You see the difference in that equation there? What would the first step there be? You have to add 2 to both sides. That's called isolating exponential term. But we didn't have to do that on this problem. We can go right to step 2, which is to use a logarithm. Now, we've got to cancel a base 16. So which logarithm would you suggest? Log base 16 here. And a log base 16 there. Log base 16 cancels a base of 16. and you're left with 3x equals log base 16 of 8. Now part of step 2 is to evaluate this logarithmic expression. You got to turn that into an actual number. What is the log base 16 of 8? That's something you should be able to do now on your calculator.
Some crazy number. Shouldn't be a crazy number. You don't remind me what you know how to do it on an older calculator. So if you have the fancy log base button, you would just do log 16 or log base 16 of 8. If you don't have that, you just use the normal log button of 8, close parenthesis, divided by the log of 16, and you get same answer, 0.75.
So that's all part of step 2. Right now we have 3x equals 0.75. Now we're on step 3, solve for x. Well, it's easy now because x isn't an exponent, it's just an expression. Divide by 3. So x equals 0.25.
So let you guys try one. No, way up. 300. Where are you? There it is, 348. 348. Yeah.
So I want you to do page 348, problem 1, got it. Right at the bottom. Bottom of page 348, the problem 1, got it.
Try that one. Using the same technique we just did.
Yeah, I suppose it is.
So we can point 4.
So, you can see this here. Do a log base 27 on both sides. Log base 27 of 81 is 1.333 repeating. Divide by 3, and you get 0.44 repeating. Nice. It's pretty much the same. Okay, check this one out. Write that one down. So now there is a bit of stuff to get rid of
before you can use a logarithm. Negative logarithm of the base.
No, that's one of those things you need to get rid of. The exponential term is just this 3 to a power of x. So the 5's got to go, and that minus sign's got to go as well.
Plus it to the other side.
There's a couple of ways you could do this.
Yeah, sure.
Well, what do you guys think? What would you do?
Get it off to make it work properly.
Okay. I agree that we should subtract 5 on both sides. So now we have negative 3 to the x equals negative 45. But that negative sign's in the way. Dang it. So divide by negative 1. Now we have positive 3 to the power of x equals positive 45. So that was an example of isolating the exponential term.
So if it was already a positive 45, would it now be negative?
Yep. Now we just proceed as if it were a normal exponential problem. How do we cancel base 3? Log base 3 on both sides. And since there's nothing up there with x, that's kind of nice. All you have left is x equals log base 3 of 45, which you can approximate on your calculator. Let's do 2 decimal spots. 3.46. 3.46? Okay. So just like with that square root problem we started with, sometimes there's a few steps to do before you can use logarithms. So try this one. Four to the power of x minus 1 plus 3 equals 21. What was the answer?
3.08. Okay, that is the right answer. Nice. Subtract 3. Log base 4 out on both sides. That cancels that. And this is what I was talking about. The 18 is inside of this logarithm here. That's why I always put parentheses, just to make sure you realize. You can't add 1 to the 18 and make it 19. You got to turn this into 2.08. Then you add 1. And you get 3.08.
That's pretty much it for exponentials, but let's just do one more before we move on to logarithms.
Well, we're solving exponential equations using logarithms. The next step is to solve logarithm equations using exponentials. It's just the opposite. But here's one. Turn down.
That's an E. That's the natural number E. See what you can make out of that one. We have 15 minutes left. Holy crap. It's a short day. I know. That would be nice. Anywho, what do you do first? Get the 7 over. What gets rid of base E? Natural log. Oh man, natural log of 22. Let's see, natural 3.09. And you subtract 2, you get 1.09. Nice. Well, here's the next logical place we have to go. Remember that equation we started with?
Yeah.
What was it? 2x minus 3 minus 4 equal, wasn't that what we started with, or something like that? Didn't you eventually have to use a square to get rid of a square root? Well, what if the equation had been... Are there similarities in how you would solve this? So what if I had given you this to start with? Wouldn't you add 4? And then what would get rid of a square? A square root, right? So we've solved exponential equations using a logarithm. What if we switched that and we started with logarithms? How would you solve those? Using a base. So these are called logarithmic equations. Logarithms get rid of bases. So what gets rid of logarithms? A base. They're just as easy to solve as exponential equations. Step 1 is to isolate the logarithm. Step 2 is to use a base on both sides. To cancel the logarithm. And once the logarithm's gone, see the problem is x is inside of a logarithm. It's no good. You can't solve for x if it's inside of a function. So you got to cancel. Excuse me, you got to cancel that function. In this case, you use a base on both sides. Once that's gone, then you can just solve for x. So let's see what it looks like on this problem. First step. Let's speed this up. We only have 12 minutes now. Speed it up here. First step. Move the negative 4 over the other side by adding. Yeah, that's the right way to go. Most of the time it's a little more obvious which base to use. This one might not be as obvious because there's no base written. But it's the common logarithm. It's got a base of 10, yeah? Yeah. So step 2, use a base on both sides. You've got to use the base that will cancel the logarithm. In this case, it has to be a base 10. Base 10 here. Base 10 there. Here's a mistake students love to make. This is not 10 times 2. What is this?
10 squared.
It's 10 squared. I see a lot of students writing a 20 out of this. But that's 10 times 2. This should be 10 squared. 10 squared is 100. So the equation is 4x minus 3 equals 100, not 4x minus 3 equals 20. 10 squared is 100. Now from here, it's a pretty easy equation to solve. Add the 3 over. Divide by the 4. You get 25 and 3/4, right? It's 25.75. Why do we use a base 10? Do we always use a base 10 every single time, base 10?
It's only because this had a base 10. If this had been log base 2, you would have used the base 2 on both sides.
So this one's kind of a tricky one. Okay, so we have 2 times the log. Oh, there's no base on that. I'm going to change this one. Let's do log base. I don't know. Let's do log base 2. 2 log base 2 of x plus 1 equals 5. Here's option 1 if you want to do it this way. And then I'll show you another way here in a second. Do you remember from the quiz what you had to do with numbers in front of a logarithm? Didn't they move up as an exponent? So option 1 is to move that 2 up and make this log base 2 of x plus 1 squared equals 5. And the reason that we would have to mess with that 2 is the logarithm isn't isolated if that 2 is in front. Now the logarithm's isolated. What gets rid of log base 2? So the next step would be to use a base of 2 on both sides. 2 cancels log base 2. So you have x plus 1 squared equals 32.
Why'd you get 32?
2 to the 5th power. It's 32. Now, x plus 1 is being squared. What gets rid of the squared? Okay, so square root to both sides. And then you have x plus 1. What is the square root of 32? 5.66? I agree and disagree.
Plus or minus.
Hey! Woo! Nobody in my last class remembered. Whenever you take a square root, it's always plus or minus. So when you subtract 1 now, you're not subtracting 1 from just one number. You're subtracting 1 from positive 5.66, and you're subtracting 1 from negative 5.66. So you're going to get two answers here. So if you subtract 1 from positive 5.66, you get 4.66. If you subtract 1 from negative 5.66,
I think this is several like messaging because the math is equal.
I hope not, you get negative 6.66. Now, I think I mentioned this once. I hope. I should have, if I didn't.
Equal.
But you might have not written it down, so I want you to write it down now, and you have to remember this. This is important. You cannot take a logarithm of negative numbers. It's kind of like the rule that you can't square root negative numbers. It's also true of logarithms. You might not remember, but back in Unit 3, I had you solve some square root equations, and sometimes when you plugged a number back in, it didn't work. You remember those? Those are called extraneous. Is this ringing a bell? Same thing happens with logarithms. Sometimes you get an answer that isn't really an answer. This is one of those cases. Check out the negative 6 answer. If you took this and plugged it back in the original problem, what you could take in the logarithm of a negative value? That's no good. So that answer doesn't work. That one does. You cannot take the logarithm of negative numbers. Now, if this were me, I wouldn't have solved this equation this way. It works. It's not a bad way to do it, but here's option 2. This is the way I would do it. It's a little quicker, I think. So we have 2 log base 2 of x plus 1 equals 5. There's another way of getting rid of this 2 in front of the logarithm. Rather than moving it back up as an exponent, isn't the 2 multiplying the logarithm? So you can undo division or undo multiplication using division. So the 2's gone. Now you have log base 2 of x plus 1 is equal to 2.5. So instead of moving the 2 up as an exponent, just divide by it. And then you could just solve it like a normal logarithm equation. How do you get rid of a log base 2? Use a base 2 here and a base of 2 there. 2 to the log base 2 cancel each other out. So you have x plus 1. And remember, this is not 2 times 2.5. It's 2 raised to the 2.5 power. And that's 5.66, right? If you subtract 1, you get 4.66. So you can solve it however you want. You can either move it up as an exponent and eventually square root, or you can just divide by it. I think it's quicker to divide by it, but it's up to you. Oh, mama. Remember how we learned last time how to put logarithms together again, condensing or expanding? Well, this is why we learned that. You can't solve a logarithm equation if there's multiple logarithms on the same side. You can't do it. Because you can only get rid of one logarithm at a time by using a base. Here's a big mistake I see students make. Don't write anything down. But I see students do this. Well, let's just do a base 10 here, a base 10 here, and a base 10 here. You can't do that. You can do one base 10 on one side of an equation and one base 10 on the other side, but not multiple. Okay? You guys see what's happening here? This doesn't work. But we learned last time, and we practiced on the quiz, we learned how to take 2 logarithms and write it as 1 logarithm. By condensing, that's what has to happen here. You got to condense first into 1 logarithm.
Now there's a plus sign between them, so are these going to divide each other or multiply each other? Multiply.
So the x minus 3 has to multiply with the x. X minus 3 multiplied by x, and that's equal to 1. So you take two logarithms, you've written it as 1. Now you can just solve it like a normal logarithm equation. This one is a log base 10, so you'd have to use a base 10 here and a base 10 there. So you have x minus 3 times x is equal to 10. Now, if you were ever wondering what in the world did that equation I had you solve at the beginning where you had to solve by factoring. Remember that one part B you had to solve by factoring? What in the world did that have to do with anything?
I'm guessing you have to factor.
Well, you've got to distribute the x. So you got x squared minus 3x equals 10.
Yep, this one solves by factoring, just like that practice problem I gave you. Where would you go from here?
Subtract 10. Ooh. X minus 5, say that again, x minus 5. It would just be a minus 5 here and a plus 2 here. So x equals 5, x equals negative 2. Now hold on, whoa! What would happen if I took this negative 2 and plugged it back up into this logarithm right here, or this logarithm right here? Wouldn't work. If you left this as your answers on a test, I'd have to mark it wrong, because x equals negative 2 really isn't an answer. It's just x equals 5. Can't take the logarithm of a negative number. All right, that's it.